Let's have a discussion about epoxy stoichiometry. And once again, I think there's certain preconceived notions with regards to formulating any type of an epoxy resin with a mono or a dianhydride, right? I mean, you've got your standard parameters, you have your epoxy equivalent weight, you have your anhydride equivalent weight. Everybody knows their standard calculations that they did when they were in university, and you do your straight up numbers. But now comes a little bit of the black magic in terms of dialing the system in to get it to do really what you want it to do. So
I think, going back to school and learning basic epoxy chemistry, you typically with amine curatives, you're working at stoichiometric ratios. And that's the way the system works the best. When you try to apply stoichiometry to mono or dianhydride systems, you run into the potential for cross-linking becoming so extensive that the material will become brittle and unusable.
But that's always that default, right? Somebody does that, then you get the phone call. Hey, this doesn't work.
Exactly, exactly. And so you really need to back off of stoichiometry, and depending on which anhydride system you're using, what actual ratio of anhydride to epoxy is going to be different. But in general, both types of mono and dianhydride systems historically have been used off stoichiometry to get you the best properties and minimize brittleness and control cross-linking in the finished product.
Yeah, and then also maybe the introduction of some empirical values too, the so-called K value, to guide you in terms of loading levels.
There's a lot of work that's been done that has been developed historically over the years on how to calculate what ratio is best used between an anhydride and an epoxy. That information is available in the literature, readily available to be looked at and evaluated.
Right.
Yeah, the mono anhydrides typically are used at 95% or 90% of the stoichiometrically calculated values, not 100% or 95%.
Right. Yeah, that makes sense.
In dianhydrides, lower than that because of being tetrafunctional.
Right. In case of the mono anhydrides, actually, we've done some recent work that shows that you can maximize the cross-link density with specific types of catalysts all the way up to 100% of stoichiometry, because we have basically diminished the level of homopolymerization side reaction to the point that we need all of the epoxides to really react with some sort of an anhydride group. So that's been an interesting development that we are just getting off now.
That's great. No, I mean, tried and true things that you're taught in university, and now we move into the little tips and techniques and just a little bit of experience, and now you're moving into the realm of really optimizing these systems.